Hello again. So in this recording, I'll be implementing both coloring algorithm, the sequential coloring and the maximum color degree coloring. So as a reminder, so I have here a graph and I need to color the vertices. So in the sequential coloring, I will loop over the vertices by label. So they are sorted by label. So I just need to loop over each vertex, and for each vertex I need to color it. So to color each vertex I need to find the color of its adjacent vertices. So for example, for A, its adjacent vertices are E and F, so both E and F are not colored, so I can color A starting from 1. So in my code, for each vertex, so I know how to loop over the set of vertices, and for each vertex I need to color it. So in the function that I will write, which is color, so I need to check the color of the neighbors and then pick the missing color. So for example, here E and F, they are not color, so I can start from 1. So my counter always will start from 1. And then I have B, so it has 1, 2, 3 adjacent vertices which are not colored. However, for example, here in C, it has D, E, and B, and 2 of the vertices and H also. So 3 of the vertices, they are not colored, and 1 B is colored. So we start from 1, we have 1, so C will get the number 2. If I move to D also, it has 1, 2, 3, 4 adjacent vertices. 2 are not colored, and B and C are colored. So I have 1, I have 2 in the set, I don't have 3, so D will be colored 3. As for E, it has 1, 2, 3, so obviously it will get 4. As for F, so I have 1, so I can color it with 2. G, so here I have 3, I have no color, so I should start from 1. So I don't find 1 in my adjacent in my neighbors, so I will color it from 1, and H will get 3. So I will not repeat the course. So I will move to Moodle and try to implement this function. So in Moodle, they are telling us to implement the sequential coloring algorithm. So they are telling us to write a function called solve that will fill in the DFS number with the color of each vertex. So we are not using another vertex, we are just using the DFS number in order to put the color there. So we have a predefined constant which is called not colored. So it's like the FS white. So just to check whether we have colored or not colored the vertex, we have a vector of integer, so this is the DFS number. We have a vector of integer, which is the adjacency list, and we have V, the number of vertices. So the function read of a graph is already there, it's already written. So printing also is already there, so we just need to fill the DFS number with the correct color, and we need to write the solve function. So we already know in our solve function, I need to loop over each vertex and color each vertex. So I need to loop over the set of vertices. So before that, I need to assign to DFS number a predefined constant, which is here in our case is the not colored. So DFS num.assign. So I know that the number of vertices are equal to V, and I will assign the constant not colored. And then I need to loop over the set of vertices. So I equal to 0, I less than V, I plus plus. So we know that if the vertex is not colored, I need to color it. So if the FS number of I is equal not colored, it means I need to color it. So it happens that if you have multiple connected components and stuff like that, so I need to loop over each of the vertices. So I need to color the vertex I. So I need to write a function color that do the coloring. So in C++, I can write the function color underneath or after the function solve, but we will stick with the C definition, so I write it before that. So I have a vertex U that I need to color. So as we have seen in the example, I need to get the color of the neighbors of U. So for that, since vertex U can have multiple neighbors, so obviously I need a vector of colors. So this is why we have a vector of integers. I will call it n colors. So this is the neighbors colors. So I need to loop over the adjacency list of U and put in the vector and colors the colors of the neighbor if they are colored. So if they are not colored, they are not colored. So I can loop over the adjacency list of u. So I can make a loop, for example, for int I 0, I less than adjacency list of let me copy it from here, u dot size, but we can use an iterator. So I'm just writing it, but I will erase it. I can use an iterator instead of these. I can use the keyword auto, and I have a variable called j that it will loops over the adjacency list of u. So for each vertex which is adjacent to the vertex u, so if it's colored, so if DFS number of j is different than not colored, so it means it's colored. So it's different than -1, so it could be 1, 2, 3, but not 0. I will add to my vector of number of colors, so I will say push back. So this is why I don't have here stand, because I don't know the number of colored vertices, colored neighbored vertices. So I will push back the color. So the color is here, is DFS, a number of j. So now I have the numbers of colors. So for example, 1 and 3 or 2 and 3, it depends on the example. So I need to start from 1 and check which number is missing. So this is why I will have a variable called color. I will initialize it from 1. So I will start from 1 and I will check which color is missing. So this is why I will have an infinite loop. Why an infinite? Because I don't know how many iterations I will do that. So obviously whenever I have an infinite loop, I need to get out of it. So I should use a break somewhere in my code. So what I will do that, I will count if there's one in the adjacent neighbors. So as you can see, for example, D, it has two adjacent neighbors or adjacent vertices with color 1. So if the counter is so it's different than 0, so it means I have the number of this color. So for example, if I have found one or more than color number 1, so I can move to the next color. So I will use the function count. So count, it will count the number of colors in the array, so in or the vector. So the vector will start from begin. So this is the, we know already that, and till end. And the third parameter is the color. So if I can count if the color 1 exists, it means, okay, I should check the next color, so it's plus plus. And if the counter or the color doesn't exist in one of my neighbors, so it's not colored, so this is the color that I need, and I can do a break. Once I get I'm out of the loop, I can color DFS number of u as the color u. So this is here u, and it will be assigned the color that I have found. So let's check and see if it's correct. So we have here count, so it's a color, not count. So it's good to see the types of error that you can get, and you can correct our code. So yes, it's correct. So let me repeat quickly. So we have write the function solve. So we looped over each vertex, and if it's not colored, I am calling a function called color that colors the vertex. So I will save in the vector and colors the color of its neighbors. So some of its neighboring vertices could have received a color, or they didn't receive a color. So those who have received a color, so I will push the color in the vector and color, and then I will loop using an infinite loop over those colors. So, and when I found the missing color, I'll start from 1. So I will assign this color to the vertex. So this is for the sequential coloring. So let's continue and move to the maximum color degree. So for the maximum color degree coloring, so I need to sort the vertices by degree. So I need to calculate the degree of each vertex. So this is why I have to previously, so before coloring each vertex, to calculate the degree. So we already know that I need to just find the size of each adjacency list. So the size of adjacency list of A is equal to 2, E is equal to 3, D is equal to 4, and so on. So I need to sort these values. So if I'll be using the predefined sorting function for making pair, so I need to pay just attention because I need to sort equal degree vertices in alphabetical order. So what I preferred in my code is that I have write my own comparison function. So we have already covered that in the first chapter, so we will repeat it here. So first I need to calculate the degree. So I'll have a vector to calculate the degrees, and then I need to sort that vector using my written comparison function, and then there's nothing to do. I just need to loop over the vertices, but not the original vertices, but the vertices according to the degrees. So it's the same code as the previous exercise, because now I know how, on which vertex I need to loop. So I will not be looping over the vertices of, so I'm not looping over the adjacency list, but I'm looping over the degrees of those adjacency lists. So let's repeat the example here. So I have calculated the degrees, I have sorted the array, and then I need to start from C. So C, again, I need to check its neighboring vectors, its neighboring vertices, sorry. So none of its neighboring received a number, so I'll start from 1, so C will receive 1. And then I have D, so D, it has just one neighbor colored 1, so it will receive 2. And then B, so it will receive 3, E, and so on. So I will not continue. This is easy. We've already covered that in the lecture. So let's move and check the solution. So I will copy these because I will need the same function color, because this is the same as in the sequential coloring. So let's see what we have in the maximum. So I will just paste it here and then read the question. So we need to do that. So again, we need to fill the FS number with the color of each vertex. So we have the constant not colored, we have the vector of integer, we have the FS number, we have adjacency list, and we have a vector of pairs of integers. So obviously we have the vertex and the degree, its degree. So if you want to use a priority queue, you can revert those. So you can start with the size of the adjacency list and then use the vector or the vertex. In that case, you can use the priority queue in order to sort the vertices. So let's write our own function. So as we have said, before doing the solution or to loop over each vertex and to find its color, I need first to calculate the degree. So this is easy. I just need to loop over the set of vertices, and I need to push back in my vector of pair. So I have degree dot push back. I will push a pair. So I can use curly braces or I can use make pair. So it depends on your coding style. So this is this is the vertex, and I need to add the adjacency list of, let me copy it from here, of I dot size, because the size will tell me the number of adjacent vertices. So, and we know that we need to cast that, so I will cast it using an integer. So now I have the degrees, so the array of degrees, but they are not sorted. So I will sort the array of pairs. So degrees dot begin, degrees dot end, and I will write my function comparison so that I can take into account not just the first parameter. So I don't just take into account the so I will sort them first on the second, and then I will sort them on the first value. So my comparison, it's a bool, so it returns a boolean, so either yes or no. It's called comparison, and I have a pair, so a pair, and then I have its pair of integers. The first one is called A, and the second one is called B. So I need to compare the second of A and the second of B. So if the second are equal, obviously I need to place them in alphabetical order. So I will place, if A is less than B, A dot first is less than B, so I will return 1. Otherwise, I will place B before A. So if a dot second is equal to b dot second, so I need to return a dot first is less than b dot first. So I will place the first one, then the second one. Else, it means that if if a dot second is different than b dot second, so obviously I need to pick the smallest one, so I will return true if b dot second is less than a dot second. So if it's too difficult for you to do that, so obviously it's a boolean, so I will try to rewrite it here in with more instructions. So here instead of this, so it means return 1. So if a dot first is less than b dot first, return 1 or return true. Else return false. So what does it mean return false? It means b dot first is less than a dot first. So in the sorting algorithm, they need to switch or to swap those values, because in my comparison function it's false instead of this. And also instead of the else, I can also write an if. So if b dot second is less than a dot second, it means they are sorted, so return true. So they are true, they are in their correct form. Else it means return false. And here it means I have b dot second is greater or equal, so it's not equal because it's already in the else, so b dot second is greater than a dot second. Okay, so this is the comparison function. So let us continue. So I have calculated degrees, I have sorted the degrees. Now I need to loop over each vertex in the vertex of degrees, not in the set of V, not of the set of vertices, and then calculate call the function coloring. So I will assign to df as to the not colored, obviously, because this is the output of my function. So I will loop over the set of vertices because the number of vertices is the same. However, here, so if df as not of I, because I will use I as a counter for degrees. So degrees of I dot first. The degree I dot first. So I'm looping over the degree of I of first. So degree, it contains the vertex number and its degree. So if it's not colored, I will color what? The degree of I first. I'm coloring the vertex I. As for the remaining ones, for the function color, so I have a vertex, I will loop over, so I will find the color of its neighboring, so it's the same as before. I will start from 1 and I will pick or find the missing color and then color this vertex with the coloring found, the color found. So let's check and see if it's correct. So we have here the adjacency list, so we have an error, so there's no I. So for I equal to 0, I less than vi plus plus, degree pushback, I have I and adjacency list I dot size. So maybe it's before that, so allocation. So I have a comma here, so it should be a dot. Okay, check. So it's correct. So let me repeat quickly. So in the maximum coloring algorithm, so I have calculated the degree of each vertex. I have used vector of pairs. So the pair consists of vertex number and its adjacency list size, which is its degree. I have sorted the degrees using my comparison function, and then I have looped over the vertices according to the degrees. So I just modified here I by degrees of I dot first. So I is my counter, and I have looped over the vector of pairs of which called degrees, and then I have called the function color, which color each vertex. This is the same coloring function as in the sequential coloring. So I have saved the color of the neighboring vertices in the vector n colors, and then I have used an infinite loop in order to find the missing color starting from 1. Once I found that missing color, I get out from the loop and then assign this color to the vertex. So, and this is it for this two exercises or these exercises. So if you have any questions, do not hesitate to use the forum or write to me. And again, thanks again for watching.